Hi, my name is Ron Dorn, and the purpose of this video is to overview two linked Hawaii geovisualization labs in GPH 112. The first lab explains the landforms or goes over the landforms of these dome-like features, the shield volcanoes on the Big Island of Hawaii. And then the second lab goes into the processes by which these dome volcanic features are turned into an erosional landscape of knife-like ridges and deep river valleys. So the first one of these labs is Hawaii Physical Geography, Geomorphology, Volcanic Landforms. And it opens up with an explanation that Hawaii is a laboratory because all the rock type is the same. It's basalt. And these dome-like features are made in volcanoes, and the volcanoes get older and they have old surfaces that can then erode into spectacular landscapes of waterfalls and knife-like ridges. So really this lab sequence is going from something like the Mauna Loa volcano, which is what island of Kauai once looked like, and then it's turned into the island of Hawaii, in which there's only a tiny piece of Kauai that is left from the original shield volcanic shape. So the volcanic landforms, the basic information is provided in this lab, but I also provide you a link to my GPH 111 lecture about volcanic landforms associated with the rock type basalt. So the format of the first question is matching, where you'll look in the geovisualization at maybe a caldera, which is a collapse of the volcano into a magma chamber that's been emptied out, a crater that's made by the force of the eruption, a cinder cone, which is where lava reaches almost to the surface, is broken up by groundwater and turns into cinder that falls back down to make a steep volcano that's made of the same material as a lava flow, and then a basalt flow, which is the lava flow that pours out of the shield volcanoes. So what you'll do is be taken to an example of a basalt lava flow on Mauna Loa, and in the game you can run back up to the top of the lava flow to determine its source, the original volcano. Or this one from the Hualalai volcano, here's your avatar, and the avatar can literally follow the lava flow back up to identify the source volcano. Or a caldera like Kilauea, where you can in the game measure that it's about 100 to 200 feet deep. In this case, a caldera that's 90 foot deep. And in this example, a cinder cone here that's about 33 meters tall, or a crater that's about 15 meters deep. So you'll have a matching question of identifying which one of these very different lava flows you're visiting. And then the second question in this lab is, can you tell apart the big five volcanoes from their features? Can you tell Mauna Kea apart from Hualalai from Kilauea? And so an example question is, if you look around the big five volcanoes and you go there in the video game, can you identify which volcanoes has the lowest slopes, the flattest terrain around its summit? That's the question. And you are given choices of Mauna Loa that has a dome-like shape at the summit, Hualalai that's pretty steep at the summit, and Kilauea that's actually the flattest volcano. So when you finish these basic ideas of constructing a volcanic landscape, then we get to destroy it in the next lab, which is waterfalls and ferrorelief or wild relief. And the questions in this lab walk you through how you go from the spectacular dome-like shape of the volcano to the landscape portrayed in this diagram of knife-like ridges with pali or cliffs and deep valleys. The idea is in the Hawaiian Islands, the further you go to the northeast, the older they get, and the more they look like the ferrorelief landscape. But the Big Island of Hawaii has mostly dome-like shapes of the shield volcanoes with only a tiny bit of this fair relief beginning to form. So one of the best places to go to understand the development of this wild relief is the Big Island, where it's just starting. So you visit the east side and the rainy east side and the dry west side. You study the precipitation differences at the same elevation. That's the first question. And then you get the idea that these valleys are made back up into the volcano by the retreat of waterfalls, that when a waterfall plunges over a giant cliff or a poly, it's eroding at the base of the waterfall. And so the next question is, you go in the video game to a very unsafe environment in the real world, where you go to the top of a waterfall and then you jump the avatar down to the bottom, or you visit a specific location and you determine the height of, in this case, a waterfall over 3,000 feet tall. And then you look at how the difference in precipitation translates into the volume of water that's flooding off of the volcano. So you make some pretty simple calculations of what water sinks in and what it doesn't, and you get to get spectacular figures of like 843,000 cubic meters of water pouring off in a single rainstorm on the rainy side, and it's a third of that on the dry side. You then figure out how these valleys widen. The valleys grow headward by waterfalls eating back up and creating the valley lengthening into the top of the shield volcano, and they widen by landsliding. It's landslides on the very steep sides of the river valleys that make them widen. And so you go through some simple calculations on calculating the slope of the side of these very steep valleys. And you can use a slope calculator. And then the last question is, what's the process that leads to the replacement of the original shield dome with knife-like ridges and deep valleys? In other words, you understand how the valleys eat back up into the volcano like Kauai, but how do you get those knife-like ridges? And this is what we're shooting for: a landscape of waterfalls with the knife-like ridges like you see on the island of Kauai. And this is what is just beginning to happen on the Big Island. Here's your avatar at the creation of the first knife-like ridge separating deep valleys. So in this helicopter mode, the avatar is going to take off from this knife-like ridge separating this very deep valley that's been eating headward from another deep valley. So I'm simply going to go from this knife-like ridge down to the coast and spin the camera angle along so you can see how these river valleys eat back up into the Kohala volcano that's 1 million years old. And then when this valley eats back up into another valley, that's when you get the knife-like ridge. Have fun exploring. It's a spectacular landscape to hike in. And most importantly, I hope that you enjoy the lab. And let me try and get out of here. You don't want to see my face. You want to see this spectacular landscape. It's an exciting thing to learn how landscapes are transformed from the original construction with volcanic domes to this wild landscape of waterfalls and knife-like ridges. Have fun.